We just talked about the range of a function a little bit in the previous problems, but now I want to make it a little more formal. And so we already said that the range of a function is just the set of all outputs of that function. We can write that a little more abstractly here by saying it's the set of all c's such that there exists an a in the domain such that f of a is equal to c. And again, sometimes people call this the image. Let's see how we could prove something about the range for a specific function. And so let's say that we have this function f, which maps r except for 2 back into the reals. And then the function is defined as 1 over x minus 2, and we want to find the range of this function and then prove that it actually is the range. And so in order to do that, first I might just draw a graph of this function, f of x equals 1 over x minus 2. And so you might remember again from sort of pre-calculus that at 2, this function is going to have an asymptote. And whenever x is bigger than 2, it'll be positive, and whenever x is less than 2, it's going to be negative. And then also as x goes to plus or minus infinity, this function approaches 0. And so from that information, I can tell that the graph of this function is going to look something like this. And I don't really care about being more exact than that in this case. That's good enough. And so now from this graph, I can see that the function should hit essentially every real value except for the 0. Because there's never going to be x value where this is literally equal to 0. And so my claim then should be that the range is equal to r minus 0. Okay, and so now I'd have to prove this. And so as per usual, this proof should take 2 parts because this is a proof about set equality. And so I want to show inclusion in both ways. And so the first thing I'd have to show is that the range is a subset of r minus 0. And so in order to do that, I'd say take any y inside the range of f. Oops, there we go. And then by definition, that means that there exists a in r minus 2 such that f of a is equal to y. Okay, and now I know the definition of f of x, and so that tells me that y is equal to 1 over a minus 2. And we just know that 1 over a minus 2 is a real number and that it cannot be 0 because there's no possible value where this would be, where the denominator would be infinity. And so we can conclude then that y is inside the reals since 1 over a minus 2 is inside the reals, and y is not equal to 0 since a is not equal to infinity, essentially. And so that implies, in turn, that y is inside the reals minus 0, which is what we wanted to show. Okay, and so now we have to show the other inclusion. And so that would be that the reals minus 0 are inside the range. Okay, and so for this part of the proof, you always essentially have to do some sort of aside here, where my goal is to take some value, x inside r minus 0, and then I want to show that there is some y such that f of y is equal to x. And so in order to do that, I'm going to need to do a little bit of manipulations because I can write what f of y is in terms of my original function. And so that would be 1 over y minus 2 is equal to x. And I just want to rewrite this to solve it for y at this point. And so all I have to do is swap the term right here and the term right here. And so if I swap them, then I'm going to get that 1 over x is equal to y minus 2, or in other words, that y is equal to 2 plus 1 over x. Okay, so this will be useful in my proof because now if I have any value of x in r minus 0, then I can tell you what you plug in terms of x in order to get f of x back. So let's see what that would look like in terms of the formal proof then. And so here we'll take again any x in R minus 0, then we know that 2 plus 1 over x is in R, and also 2 plus 1 over x is not equal to 0. And so the point is, or sorry, that's not equal to 2, just because 1 over x can't be equal to 0. And so that implies that 2 plus 1 over x is inside R minus 2, which is the domain. And then also, we know that f of 2 plus 1 over x is equal to, by definition, 1 over 2 plus 1 over x minus 2, which simplifies to x. Right? And so in this way, then, we found an input, 2 plus 1 over x, inside the domain, where f of that was our desired output. And so that proves that R minus 0 is a subset of the range.